Hey, there's a viewer. Who is it? Hey, there's a viewer. Who is it? So I turned on the group chat for the Hangout, and if you want to type there, you can do that, or type in, just send me a message in Facebook Messenger. I don't know if there's a way to have other people's video join this, but I don't think so. Okay, that's actually almost like well, there's one viewer. I don't know who you are, and I'm expecting like 2 or 3 people, so we're gonna hold off on starting. There's group chat on the Hangout. I don't know if you can see that, but I don't know. I've never done this before, so I don't know if YouTube. I don't know if YouTube comments show up. I'm viewer. I don't know who you are, and oops, turn that off. I don't know if like YouTube chat shows up here or something. Nope. Probably me. Hey, so there's a group chat. I don't know if you guys can see it in the Google Hangouts. If you can, please say something. Otherwise, I don't know. I guess you can send me a Facebook message or whatever else in the YouTube comments maybe. It's a little weird doing this without any any feedback. So I see that I have 4 viewers, but I have no idea who they are or what, if they're ready to go. Oh, okay. Hey, somebody says I don't see group chat. Well, that sucks. All right. Okay, so so I don't know if we have a way to apparently you guys can't see the group chat. There is a group chat. So if you can see that, feel free to ask questions there. Otherwise, you can send me a message on Facebook Messenger, and I will try to address it, whatever question it is. I guess I will get started because it says we got 4 people, and 4 people might be about all we're going to get. So, so there's okay. So this was a problem from the HackerRank Spring Code Sprint, and the problem is basically you have a bunch of people that you need to get assassinated. So we'll call them victims. You have N victims, and you have K hitmen. And the question is, each hitman has a cost to kill each victim. Those costs are all independent. And hitmen, if you number the victims 1 through N, hitmen can only kill like 1 adjacent series of victims. So, like for example, you could kill, indexes 0, 1, and 2, but you can't also kill 7. So the question is, how do you find the minimal cost for a given set of costs in Hitman, whatever. Okay, so let me write this down. Okay, so we have So this is hitmen is in the range 1 through 10, and victims is in the range 1 through 25, I believe. Can people see that? Oh crap, there's a reflection right there. Worse. Okay, so okay, so the suspicious thing about this problem is that the constraints are really low, like really low. So there's only 10 hitmen at the most. So what we need, I mean, there's a couple different ways to do this. You could do this recursively. You could do this whatever. But in general, for this type of problem, there's going to be two fast ways to do it. You can either start like at a final, something close to the where the top and work your way down recursively, or you can start at the bottom and build your way up. So, for example, if you want, like if you were calculating Fibonacci numbers, you want to know what the 26th Fibonacci number is. You can start with f of 26 and have it recursively call, f of n minus 1 and f of n minus 2, or you can start at the bottom and just add up the numbers, right? So you can just calculate f of 0, f of 1, f of 2. So if you start at the bottom and build up, that's called dynamic programming. So you basically allocate a big array, and you're going to start at the very bottom of the solution. You're going to build your way upwards until you get where you need to be. So in this case, the only real complexity in this problem is figuring out how you can array. Like basically any dynamic programming problem, the hard part is figuring out what you're storing in the array. So in this case, it's like pretty clear that like most dynamic programming things, we're going to start with 0 people killed, and we're going to work our way up to the maximum, 25 people killed. So we're going to have an array, right? So call it dp, and there's going to be 2 dimensions. So one of them is going to be people killed. And then the other one, oh crap, it's backwards. That's unfortunate. I wonder if it's backwards for other people. Is it backwards for you? Is the text backwards? Okay, I'm going to assume it's not backwards. I think it's just mirroring it locally. Okay, so we're going to have a DP array. So one dimension is killed. The other dimension is hitmen. Like we need to keep track of which hitmen are used for this solution. Okay, so how do we keep track of that? So we have 10 hitmen, but remember we can't just look at who's, it's not just 1 through 10, because we could use any subset of those hitmen. So what we need to do is we need to store who's actually, we need to be able to store who's actually used. So we're going to do that by storing like a 10-bit number, right? So we're going to store hitmen. But this is going to be a math. So as an example, if we had we'd have, a number. This is written in binary, so you'd have 000 indicates none of the hitmen have been used. 001 would indicate that like this hitman has been used. 010 would indicate the middle hitman has been used, and so on, right? So in this way, we can express any combination of who's been used and who hasn't been used. So what does this tell us? So if we have, because the constraints say only 10 hitmen, we know that the total size of this mask is going to be 2 to the 10th, which is approximately 1,000. 1024, right? So we know that this is going to be pretty small. Like even if we do number of people killed, that's going to be 25 times 1,000, 25,000 cells in our array. That's definitely going to fit in memory, and it's definitely, we're going to be able to calculate the values of each cell without worrying about running out of time. Okay, so that's it. So that's pretty much the major insight of the problem, is that you can use a mask to represent people, represent which hitmen are used. And so now what we're going to do is we're going to basically start with the bottom solution and work our way up to the real thing. So so in this case, so I'm going to use the example here, and I'll just do the example by hand. So like one useful thing, just in general, like if you're doing an interview problem or something, is to actually do things by hand. Like before you actually write a bunch of code, just try solving it by hand. And that can help you find, see if there's a problem with your approach or whatever. Okay, so I'm opening up the problem here. So in the example, we have, there's 3 victims. So we've got costs. So the costs are 1, 4, and 2, 2, 2. 1, 2, 2. So this is 1, 2, 0, 1, 2. Okay, so so how are we going to? Oops, you see that? Okay, so how are we going to actually compute this? So I think the way I did it, was with these 2 reverses. So I'll just reverse them. So what we're going to start by doing is we're going to have like an array. So one direction we'll have our masks of hitmen. So in this case, we've got 0, 0, 0, 1, 1, 0, 1, 1. These are the 4 possible masks. And then in the other direction, we've got the number of people killed, right? So 0 people killed, 1 person killed, 2 people killed, 3 people killed. So the goal with dynamic programming is we're going to start way at this end, and we're going to gradually fill in all these cells. And basically, when we fill in each one, here we can use like the table entries that we've already produced, along with whatever, some additional information to produce this cell. And so we'll fill it out from this side. And we're just going to put infinity for the cost of everything that we don't know. Okay, so we'll start here. I'll just erase this stuff. So okay, so this is killed in one direction. And this is Hitman mask. I apologize for my terrible handwriting. Okay, and once again, the costs are 1, 4, 1, 2, 2, 2. Okay, so we're gonna just say, so we're filling out this first column. We're gonna just initialize everything to infinity. We don't know about. We're just gonna have infinite costs. And you can just pick some large constant that's bigger than any possible valid cost, and use that as infinity in your program. So everything is initialized to infinity except this one cell. So if we have used 0 hitmen and we've killed 0 people, we'll say that costs 0, right? That's a pretty intuitive value. Okay, so now what we need to do, when we look at each additional cell, so we're basically going to iterate through all of the hitmen. So there's 2 of them. We're going to iterate through them. We're going to see if they're used by the current mask. And if they're not currently used, then we're going to compute the cost of using that hitman for every remaining cell. Okay, so what we're going to do, so first we're going to iterate in this direction, going through here. Then we're going to iterate in this direction. And actually we can just start with 1 because we don't need to fill anything else out for 0. So for 1, what we're going to do is we're going to say, okay, here, let me see. Hang on a second. Okay, so actually we'll start with 0, I guess. So we'll start with 0, and then for every possible mask, that is every row, here we're going to see, okay, is this hitman available to be used? So for every possible mask, we're going to iterate through every possible hitman, see if it's available for use. Okay, so we're at this one, so we're going to iterate through the 2 hitmen. This guy is used, this guy is not. So the only thing we can do here is we can kill, or we can use this hitman. So let's number these guys. Hitman 0, 1, and then victim. Okay, so in this case, hitman 0 we can't use because he's already been used. Hitman 1 we can use, so we can just fill in the costs. So this actually stays as, but we can just fill in the costs using hitman 1 for 1 guy, for 2 guys, for 3 guys, etc. And actually, sorry, what we're going to do is, before we do that, we're going to look at, so our mask here is 0, 1. So we're actually going to fill in on row 1, 1, because this will be after having used an additional hitman, right? So here we're going to say 2. So this is. So we've said, okay, if we use hitman 1 and we use, I guess we can use hitman 1 to kill, 1 extra person. We can use hitman 1 to kill 2 people, or Hitman 1 to kill 3 people. And these are the costs. Actually, these should be the sum. So this will be 2, 4, and 6. So that's what we'll write in here. So this is only considering Hitman 1. And then we'll do this again, but with Hitman 2, or Hitman 0, I guess. And then for each one of these, we will take like the minimum, right? So we'll say Hitman 0, you know, he can kill this guy with 1, with a cost of 1. So we'll fill this in as 1. He can kill these 2 with a cost of 5, but this is lower, so we won't change it. And he can kill all 3 with a cost of 6, so we won't change that. Okay, so then we've iterated through this. So then we'll go back through here. So this would actually be yeah, sorry. So when we process this one, we'll say 0, 0, 0. So there's 0, 0 are the 2 hitmen here. So if we just use hitman 0, then we'll fill in like 1, 4, 1. Sorry, 1, 5, 6. And if we use hitman 2, it'll be 2, 4, 6. And then this would be using both of them, having used both of them. So what this represents, what this cell represents is, if we've used both hitmen and we've only killed 1 person, what's the cheapest price we can get? And like by 1 person, I mean like the first person in the array. So if we've used both hitmen, then the cheapest price we can get is 1. So now we'll just iterate through this again, right? So we'll use, so we'll say, okay, we've used, in this case, we've used, let's see. Okay, so I guess we'd go down, this column, right? And we'd say, all right, we've used this hitman, so we've used hitman 1, and that cost us 1. But now we still have hitman, or we've used hitman 0, so we still have hitman 1 available, so we can take hitman 1 and take this cost so far, plus the cost of having hitman 1 kill the remaining people. So we can take, in this case, we'd say 1 plus the cost of hitman 1 killing victim 1. So this is 1 plus 3. So we would take 3 and put that here, because we found a cheaper. So we've now found a cheaper price for killing 2 people. That makes sense. And then for 3 people, so we'd say, what about having hitman 1 kill both of these people? That would be a total cost of 4. So now we've got like 1 plus 4 more. So that would be a total cost of 5 here, right? So basically what we're going to do is we're just going to fill it out, top to bottom, left to right, and we're going to, when we get to the end, we can just look at all of like this entire column, because this represents, all the costs of getting everyone killed using some combination of hitmen, and whatever the minimum is in that column, that's our answer. So let me see if there's questions and stuff, because I'm kind of rambling. Okay, no questions. Okay, so let's take a look at what this code looks like. So I could write it on the whiteboard, but I can also just show it. Let's see. I think this thing can do screen sharing. Screen sharing. Cool. Okay, so here's the code. Um, let me see if that's. All right, so we're going to start out. So we've got N is our victims, K is our hitmen. We read in N and K. Cost is going to be the cost for, this is indexed as hitman victim, so the cost for a given hitman to kill a given victim. So again, we're just reading the input, blah, blah, blah. I don't know why they did the indexing backwards. Like they say you have to kill them from the, like, the first, you can kill 25 and 26, and then the next guy has to kill it. So I just reversed it so that it's a much more intuitive way. Okay, index 0 means we're killing 0 people. Index 1 means we're killing 1 person, etc. Because we're only looking at the total cost, we can flip the array without it mattering. Okay, so we're inputting all this stuff. So then we've got mask. So mask is just 2 to the k, where k is number of hitmen, and we're filling our DP array with INF, which is short for infinity, right? So this is some really big number, big enough that you know, it won't ever occur. And you know, in this case, I was printing out stuff to debug, so I made it a bunch of 9s. So that's it. So for then hitman available and use hitman, these are you know, written out for clarity. So this is just some bit masking. So given an existing mask, you know, a number with 1s and 0s, we want to return that same mask but with a certain hitman used. So what we do is we take that mask or 2 shifted by a number of hitmen. So if it's 0, if it's hitman 0, the 2 will be shifted by nothing, and it'll be, you know, it'll just be a 1. Oh, sorry, that should actually be, oh well. This should be a 1, well, anyway. And yeah, so same for like, is a hitman available? These should be 1s, but that's okay. So you can just take, you know, 1 shifted by whatever hitman it is, and it with a mask. And so let's say we've got, so used is 1, 0, 1, and we have hitman 2 and 2. So what we do is we would take a 1, we'd shift it over by 2 positions, and then we'd AND these 2 numbers together. So if you do 101 and 100, then you get this, because 1 and 1 is 1. And yeah, so that's it. So then we just iterate through the number of already killed people from 0 to n, and we iterate through every possible combination of hitmen for, or every possible mask, which is a combination of hitmen. Then for each combination of hitmen, we check for we iterate through all the available hitmen, and we see, okay, if we use that hitman, what would the cost be? So we're saying, we're essentially, for every cell to the left of the one that we're currently processing, sorry, to the right of the one we're currently processing, we're going to say, hey, is it cheaper to do this? Which is to say, is it cheaper? Is like the current value of that cell cheaper, or is it cheaper to do like the price of the current cell plus the cost of using this new hitman to kill everybody in this given range, right? So we're going to see, okay, is it cheaper to use you know, whatever we've already used, whatever combination of hitmen we've already used, or is it cheaper to use this new guy to kill some range of people? And we're going to iterate through all the possible ranges of people. So we're going to, you know, using the new guy to kill, you know, 1 through everybody left. Those are the combinations. And then that's it. And then at the end, we just print the minimum of that last column, and that gives us our solution. So I'm like pretty rusty on DP stuff. So this took me maybe like a half hour or 45 minutes in the competition. But I think it's like a pretty straightforward DP problem, like two-dimensional dynamic programming. And the main thing is just to realize that you can represent a set of hitmen as a mask. And like after you've done that, everything else kind of falls into place. So do you guys, here, I'll turn this off. Okay, so does anybody have any questions or I guess stuff that I can answer? I'll put the link up. So you can go to github.com/dalves. So if you go to github.com/dalves, you can then click on HackerRank, and you can eventually find your way to the source code. So this is stuff that I wrote during the competition. So not all of it's, you know, perfect. Like I used 2 shifted around instead of 1, but it works. Yeah. Anybody, any questions or anything? Or I can go over another problem if somebody wants. Oh, there's some. Yeah, okay, so Kevin is saying that he couldn't go into the chat room. Yeah, I don't know how to turn on, I mean, it says it's on. I don't know how to actually turn on the group chat, or like how to enable that for other people. So you're gonna have to just ask messages over Facebook Messenger, I guess. Or I mean, if you post a comment in the group, I can do it. Oh, find the seed. Yeah. Oh crap. Oops. Oh well. YouTube link was set to start at the very beginning. So you get to look at 5 minutes of me sitting around with nothing. So Zhang wants to know how to find the seed. I don't know. I mean, I looked at that for like maybe 10 minutes or something, and then I was like, okay, screw it. Yeah, I don't know how to do that one. Or at least I would need to look at it for a lot longer to figure it out. That one is quite hard. The pass rate, I think, was 13%, whereas the pass rate for this one was like 30, 40%. Yeah. But I mean, I don't know. I guess I could try and research it and get back to you guys or something. I think it's much more difficult than anything you'll have to do in an interview or anything like that. Oh, okay, HipChat. Let's try this. Okay. So now we can, I mean, this is the same two people that were talking on Facebook Messenger. So yeah, I don't know. I mean, do you guys have any other questions? I think most of the other problems were pretty easy, but I'm happy to go over them if people want. Oh, I have a pretty short solution with for connected cells in a grid. If you guys are interested in that. So I mean, I guess I might as well. So the connected cells in a grid problem was you're given a grid of ones and zeros. A contiguous region of ones is, you know, however many ones are in it, that's the size, and you need to find the size of the largest region. And in this case, contiguous includes, you know, up, down, left, right, as well as diagonals. So you're given a grid and you need to find the size of the biggest region. Okay, so so the solution, or my solution for this is, it's pretty straightforward. It like uses a, it's actually very straightforward. It's very short. Okay, so here's the solution. So we take input, you know, R and C, that's number of rows and columns. I find that it's much more useful to use R and C for rows and columns instead of using X and Y, because it can get confusing about which one is which if you use X and Y. Okay, so then I input the grid, and then I have this recursive method. So countum, if you do countum RC, that will count the number of things at a given position. So it starts with, okay, check if I'm out of bounds. If I'm out of bounds, return a 0. Otherwise, if it's a 1, then I'm going to set it to 0, and I will return the sum of 1 plus countum on every adjacent square, including diagonals. Otherwise, if it's a 0, just return 0. So this has kind of a cool effect that if we call countum on one square of a region, it will, as it recurses downwards, it will zero out the cells that have already been counted, so it won't count them again. But it won't like zero out anything that before counting it, or zero out, you know, like cut off some region with zeros and like not count a full region. So anyway, I mean, I think this is a pretty short solution for this problem. So I was pretty happy about that. And then so we just iterate through every position, like every R and every C, and we say, okay, biggest is the maximum of biggest, and count them at that position. Yeah. Oh, Capricorn numbers. Okay. So Capricorn numbers. Yeah, so I don't actually remember this problem that well. Oh yeah, so it was like, so Capricorn numbers was like if you split the digits of a number in half, and then wait, okay, so you take a number and you square it, and then you split the like that squared number in half, and if the front digits plus the back digits are like equal to the original number, then it's a Capricorn number. So I think the example they gave was like 45 is a Capricorn number because 45 times 45 gives you 2025. So 20 plus 25 is 45, right? So if you split the square of it in half and then add up the two halves, then it equals the original number. Okay, so this is the Capricorn solution. So we square it, so that gives us squared, and then we say, okay, the midpoint of squared. We basically take the midpoint of the. Oh yeah, so we turn it into a string. So we square it, turn that into a string. We find the midpoint. It's the length of the squared thing minus the length of the original thing. And then we say, okay, A and B, these are going to be our two halves. So if you're not familiar with this notation, this is slicing in Python. So this is basically saying every digit from the midpoint afterwards, and this is saying every digit from before the midpoint. So we say, you know, A is whatever, B is this. We also have to say, wait a minute, if the length of the squared thing is, if it's only one digit, then we need to set B to 0. And then if A plus B is equal to N, then we're done. I'm not, actually, I might be misunderstanding the question here. He said, is there like a way to do it other than brute force? I mean, this is still brute forcing over every number in the range. Yeah, I don't know. So this is still brute forcing over every number in the range, but I believe the range was pretty small, so it doesn't really matter. I don't know if there's a faster way to do it. I mean, the faster way to do it would be look up, you know, what Capricorn numbers are there. Oh yeah, so the range is up to 100,000, but I mean this will run very fast. So yeah, so this will run super fast. The only thing is we're converting to a string, but we could easily do up to 1 million or 10 million or something. And if we needed it to be way faster than that, then I would suggest pre-computing all the Capricorn numbers, because there probably aren't that many, and pasting them in, and then printing out the appropriate range of Capricorn numbers from there. Yeah. I don't know. Any other? Let's see. I noticed. Okay, so Kevin says, I noticed that the Capricorn numbers, if you modulo by 9, it returns either a 0 or a 1. Okay. Cool. Yeah, I mean, I don't know anything about Capricorn numbers other than just like how to write, how to check if a number is a Capricorn number. Yeah, I don't know. So anyway, I guess we should probably call it, unless people have other questions or whatever. So you can go to github.com/dalves, and you can navigate from there. You can find the solutions that I wrote during the competition. So here they are. I think in general they're pretty short. So maybe useful for like even if they're not even if it's not a particularly interesting problem like this one, I think it can be kind of cool to see, okay, how can I write this really concisely, like, and that can kind of help you get better at writing nice, like, concise, clean code. So, yeah. Doing it in Java was a pain. Well, it's Java. Yeah, so in general, on these competitions, I would almost always use Python or like Ruby or something like that, because like well, it depends. Like when you're mostly worried about coding speed, I would always use those. If you're worried about execution speed, then yeah, use Java or C or something. But like basically the thing that I do is for easy problems in coding competitions, I always use Python because I can just, I can code something up so much faster. And then if I think that execution speed will be an issue, then I will do it in Java or something. But like Google Code Jam, for example, I almost always do the problems in Python, and it's only in like if I make it to the later rounds that I'll start doing things in Java. Yeah, but actually on HackerRank there's even less reason, because if you use Python, they give you extra time, whereas Google Code Jam doesn't. So there's there's even less of a disadvantage to Python or Ruby or whatever high-level language. Okay, cool. So I guess we'll call it. I hope that was useful. I'm sorry for kind of rambling on the blacklist problem. It's it's a little bit. I guess like the code is pretty short, but it's kind of confusing to explain it. So hopefully that was useful for people. Okay, I'll see you guys next time.